In this video, we're going to work on writing equations from tables. Again, everything that I write down in this video needs to be written down in your video notes. So let's just review. We know that we've been working with y equals rise over run times x plus b. Okay? We're going to keep working with the same stuff. So rise over run, that's our slope. We rise up or down, so that means positive or negative, and we run right. And our rise and our run this time are going to be a little different, but we'll talk about that. Our B is our y-intercept. It's where x equals 0. It's the point 0, comma b. And this is what's really important today, is it's where x equals 0. So if we get into it, there are going to be 5 steps to writing an equation from a table. Okay? First, again, we're going to start with that blanks, or those blanks that we did with writing equations from graphs. So we're going to fill in a blank for the rise, for the run, and for the y-intercept. The first thing we're going to find here, we're going to start with the slope. So we're going to find the rise first. And for the tables, we're going to call that the change. And this triangle means change. The change in y. So I'm going to add a change in y column to my table. So from -3 to -1, I add 2. From -1 to 1, I add 2. From 1 to 3, I add 2, and from 3 to 5, I add 2. So it's fairly clear here that my rise is 2. So I plug that into my equation. Then I'm going to find my run. And for the run, that's the change in the x. Okay? So my x is changing from -2 to -1. That's plus 1. From -1 to 0, that's plus 1. 0 to 1, plus 1. 1 to 2, plus 1. So my run would be 1. So I can add these 2 columns and help myself. Step number 4 is to find the y-intercept, or to find b. And that's where x equals 0. Okay, so sometimes it's going to be really easy, where x equals 0, y equals 1, so that's really easy. But sometimes we'll have to find it. We'll have to do a little bit more work, and we'll talk about that in some examples. And then the last step is just to finish the equation. And so our equation is y equals 2 over 1x plus 1. So pause the video, get all those down if you don't have them, and let's move on to our first example. Okay, so we're going to need y equals rise over run times x plus b. So I'm going to start with my rise, so my change in y. Here I'm going down 0.5, so down 0.5, down 0.5. And I'm writing all these because sometimes it won't be the same every time. So it looks like my rise is 0.5 and it's a negative. My run, my change in x, is going up 1, up 1, up 1, up 1. So 0.5 over 1. And my y-intercept is 3. Okay? Now, 0.5 over 1, we don't really use decimals as a fraction. So 0.5 over 1 would just be 0.5. So let's think about what 0.5 is as a fraction. Well, that would just be -1/2 x plus 3. And if we look at this, half of 0 is 0 plus 3 is 3. Half of -1 would be a negative half of -1 would be 0.5 plus 3 would be 3.5. Negative half times 1 would be -0.5 plus 5 is 2.5. Half of 2 is 1. or negative half of 2 is negative 1, plus 3 is 2. So then they have some empties here. Let's fill this in. Let's say if we continue our pattern and we have 3 and then 4. Well, if we plug in 3, that would be, so let's plug this in, negative 1/2 times 3 plus 3. So negative 1/2 times 3 is going to be negative 1.5, and then plus 3 would give us positive 1.5, and we can see that would follow our trend here, minus 0.5. If we plug this one in, negative 1/2 times 4 plus 3, well, negative 1/2 times 4 would be negative 2, plus 3 would be 1, and again that follows our trend, negative 0.5. So our equation here is y equals negative 1/2 x plus 3. Here, we're not given a whole bunch, but we can still find what we need. So we need y equals, we need a rise, a run, times x plus b. Okay? So I'm going to make my change in y table or column and my change in x column. And from 11 to 15, I rise 4. I add 4. From 23 to 27, I add 4. So it looks like my rise is going to be 4. From 1 to 2, I add 1. And from 4 to 5, I add 1. So my rise is 4 and my run is 1. Notice I don't have a 0 though. I don't have a y-intercept. But it looks like if we fill this in, this could be 0, this could be 3, and this could be 6. So we could just fill in what we know using our pattern. And we know here this should add 4, and adding 4 to 15 would be 19. And let's see, 19 plus 4 equals 23. Good. So then if we add 4 here, we should get 31. Because all of these are adding 1s. So we are keeping our rise and our run the same. But if we go backwards, so what plus 4 would equal 11? Well, we can take 11, do the opposite, minus 4, and that would give us 7, right? So then our y-intercept becomes 7. So our equation would be y equals 4 over 1x plus 7. Again, here we're missing some of our information, but we can go ahead, fill in our blanks. We're going to have rise over run times x plus some b. If we have our change in a y table, or column, from negative 7 to negative 1, that's adding 6. And from 9 to 17, well, that's adding 8. So we don't have the same there, but watch what happens. If we go over here to our change in x, from negative 4 to negative 1, well, that's adding 3. And from 4 to 8, that's adding 4. So what we can see here is that if we take our slope would be our rise over our run. So rise over run. And in table language, we kind of call that change in y over change in x. Well, here that would be 6 over 3, and here it would be 8 over 4. But both of those things reduce to 2 over 1, right? So our slope then, in the most reduced form, can be 2 over 1. And then we can use that to fill in some blanks. So the most important blank we need is 0, right? We need our y-intercept. Well, it looks like 0 could go right here. And if 0 went right there, we'd be adding 1. And for every 1 we add, we know we have to add 2 here. So this would be negative 1 plus 2 would be positive 1. So our y-intercept would be 1. And down here we could do whatever we wanted. We could add, let's say this is 10. Well, we know so from 8 to 10, that's plus 2. So if we add 2, we need to make this ratio equal here. So if we have the change in x is 2, well, the change in y needs to be 4. So 17 plus 4 would give us 21. And then let's say we'll go backwards here, and we'll just keep with this. If we keep with what plus 3 equals negative 4, well, that would be negative 7. And if we're going to do that, we have to have what plus 6 is negative 7. Well, that would be negative 13, right? Negative 13 plus 6 is negative 7. And to check these things, we could put it into our equation. So if we plug this one in, let's say maybe we didn't do this right. 2, we would say, does 21 equal 2 over 1 times 10 plus 1? Well, 2 times 10 is 20, plus 1 is 1, or 21, and we're good. So our equation here is 2 over 1x plus 1. So you're going to go ahead and try some problems on your own or work with your teacher. That is writing equations from tables.